Today we're continuing about what we spoke about last week, right? So we spoke about formulas of compounds and I showed you guys how to name the compounds, right? But today we're going to talk a little bit about the actual formula of a compound. Firstly, a compound is a substance consisting of two or more different elements bonded together. So if I look at a compound of water, right, we have hydrogen and oxygen bonded together, and they both are different elements. Secondly, each compound could be written as a formula, right? So there's a fixed formula for each and every compound on Earth. A formula is a ratio of symbols of the elements and the number of atoms of each symbol in the compound. So let's put that into practical. So we have the compound for water, right? H2O. Ignore the 2 before the compound. We see here that in every single compound of water, there will always be 2 atoms of hydrogen and 1 atom of oxygen. And if you look at the accompanying diagram there, we have 2 atoms of hydrogen and 1 atom of oxygen, right? We call those little numbers next to the atom or the element, we call it a subscript, all right? So the subscript never changes, but the number that comes before the compound, that can change. That tells me how many compounds they are, right? So in this case here, we have 2 hydrogen compounds. So this is how it will look, all right? If I put a 3 before H2O, then I'll have 3 molecules of the hydrogen compound. Okay, so like the word H, the letter H rather, and the letter O, those are called symbols, as you might have remembered from before. The same thing with CO2. CO2 is carbon dioxide. The letter 2 is the subscript. There is an imaginary 1 next to the symbol C. All right. So we don't put it, but we know it's there. And if we apply this into a model, we see that there is 1 carbon and 2 oxygen atoms for every molecule of carbon dioxide. But there is a coefficient. A coefficient is the number that comes before the compound, before the name, right? The coefficient tells us how many molecules of the compound that there is, right? So here we see there are 2 compounds of carbon dioxide, so it's going to look like this, right? And because it's a gas, they don't touch, because gases they move freely, right? It's not a solid. Okay, let's move on. Right, so when we're looking at a formula, right, a formula shows a few things. It shows us which elements the compound is made of. It indicates the ratio in which atoms of different elements are bonded together. A ratio you guys have done in maths. It's like with every 2 hydrogen atoms, there will always be 1 oxygen atom. If that kind of ratio does not exist, right, or if maybe there's like 2 oxygen atoms with 2 hydrogen atoms, then that's not water, okay? Thirdly, it gives us the number of atoms of each element, and it indicates the total number of atoms in one compound. So I know this must be a little confusing for you. Let me give you an example of this. For the formula of copper sulfate is a compound. And if you guys remember from the previous lesson, SO4, right? SO4 is basically a sulfate, right? And if I put a metal before sulfate, then you just name the metal and name sulfate along with it. Firstly, it consists of the elements copper and sulfur and oxygen. Can you see that there are 3 elements in this case? The ratio in which the elements are bonded is there's 1 copper, there's 1 sulfur, but can you see that there are 4 oxygen atoms there? So you write it as 1:1:4. Okay, this is a very important component here. All right, then secondly, it contains 1 copper 1 sulfur, and 4 oxygen atoms. So we're basically just rewriting whatever we've spoken about in the previous point. In total, there are 6 atoms in this compound. So let's count why there are 6, right? So we have 1 copper plus 1 sulfur plus 4 oxygen. If you add them all up, 1 plus 1 plus 4, you get 6 atoms. All right. Let's do this. Let's put a coefficient of 2 before copper sulfate. All right. So guys, what we do with coefficients is that it works like maths, where you take the number or the coefficient that comes before the compound and you times it by all of the subscripts. So 2 times 1 there and 2 times 4. Okay. So if we had to count the number of atoms in this compound, we'll have 2 copper compounds, elements, 2 sulfur atoms, and 4 times 2 is 8. So we'll have 8 oxygen atoms. Okay. All right, moving on. Let's do this where you guys actually help me with the answers. Just adding 0. Okay. Right, so the next compound we have is potassium nitrate, right? K stands for potassium. Remember that NO3 stands for nitrate, just like SO4 standard for sulfate, right? So if we look at potassium nitrate, it contains the elements, and you guys tell me in the chat which elements does it contain. Okay, so tell me which elements is within the compound KNO3. Okay, so Christopher said potassium, nitrogen, and oxygen. Well done. Okay. Right, so it consists of the elements potassium, nitrogen, and oxygen. Okay. Right, the ratio in which the elements, and we know that it's K, N, and O, is bonded is. Guys, give me the ratio of the elements that are bonded. So tell me in a ratio, write for me. How many Ks are there, how many Ns are there, and how many Os are there? And remember, a ratio is like 1:9:0. And I want all of you to try and attempt doing this. Yes, so there's 1 potassium, there's 1 nitrogen, and there's 3 oxygen. Well done. All right, so how come those consist of elements? What do you mean, Gabs? Remember that this is a compound, right? But a compound is made out of elements. And which elements is this compound made out? It's potassium, nitrogen, and oxygen. Okay, but what is the ratio that where the elements are bonded in the compound? Well, in order to get potassium nitrate, you need 1 potassium atom, you need 1 nitrogen atom, and 3 oxygen atoms. How come those consist of elements? I hope I answered your question. All right, so it contains altogether, not altogether, but anyway, 1 potassium atom, 1 nitrogen atom, and 3 oxygen atoms, right? In total, can you guys count how many atoms there are in this compound? How many atoms are there all together? Well done. Well done, guys. I think you guys are getting the hang of this. All right, so let's continue with the next question. So I'm going to give you guys like a lot of revision questions just to make sure that you know what you're doing. All right. Question number 1. What is the meaning of the subscript 3 in the formula above? So the subscript is the small number next to the symbol. What does that subscript mean?
Wait, sorry, ma'am. Repeat the question.
Okay, so my question was the subscript of 3, what does it mean in the context of the compound?
Am I correct if I say protons and neutrons?
You close?
Yeah, electrons.
Okay, so I'm going to add to your answer, right? The subscript 3 tells me, as Michael is saying, the amount of oxygen atoms. So the 3 here tells me that there are 3 oxygen atoms. Because there's no number next to nitrogen, we know that it's 1, right? There's 1 nitrogen atom. And because there's no number next to K, we know that there's also 1 potassium atom. Does this make sense, everybody?
Yes, ma'am.
Okay. I'm just checking my WhatsApp. Someone is really trying to get hold of me. Oh, and that is what you got. Okay. Let's look at number 2. What is the total number of atoms in the compound if I add a coefficient of 2 before the compound? Okay, so let me enlarge this quickly. Right. So now that I've added a coefficient of 2, I want you guys to calculate for me. How many potassium atoms are there? How many nitrogen? And how many oxygen? And I'm going to help you a little bit here. My clue here for you is that you times the 2 by every subscript of the compound. Okay, thanks for answering me there, guys. So, how many atoms is in this compound for every element? Write it for me in a ratio form. And I'm only going to answer you guys until everyone has attempted. So you're going to write it for me in this form here. But just tell me how many atoms there are. Christopher may be correct, may not be correct. I want all of you to try. Okay, Mo has 4 numbers there. Mo, there's only 3 elements, so they cannot be 4 numbers. Because each number stands for 1 element. Okay? Close. Close, Mo. But you're not calculating something right there. All right, I see Michael. He's getting it. Put it in a ratio, Michael. Okay, I'm going to give you guys the answer. So the answer is there are 2. Ooh, that is huge. There is 2 potassium, 2 nitrogen, and 6 oxygen atoms, right? I don't know why this 2 is so huge. Anyway. Why is it 2? Because 2 times 1 is 2, 2 times 1 is 2 again, and 2 times 3 is 6. Okay? Kian said Ish. What is wrong, Kian? Is this complicated? I'm going to give you guys another one. Try working this out.
And
Yes?
Letehu says she doesn't understand. She accidentally sent it to me privately, but she says she doesn't understand.
Okay. Letehu, send me a message and tell me what are you not getting. Okay, so for those of you who understand, please work that out for me. For those of you who are still getting around it, let me go through this again, right? So we look at this formula here. Every single compound on Earth has a chemical formula, right? That's how we know how many elements are bonded in the chemical formula. How many nitrogen, how many hydrogens are there in water? How many oxygens are there in water, right? So if we look at the compound of potassium nitrate, right? K stands for potassium, NO3 stands for nitrate, right? Here we see that there is only one potassium atom because there is an imaginary one next to potassium. And we see that there is also only one nitrogen because there's an imaginary one next to nitrogen. Same with oxygen. There is 3 oxygen atoms here because there is the subscript of 3 next to that symbol. A subscript is a number that goes directly next to the symbol. Okay? And just to recap the first one here. So the first question I asked you is that which elements, right, is consisted within this compound. So you just need to tell me, okay, so I see potassium, I see nitrogen, and I see oxygen. Secondly,
Oh, sorry.
is it making sense? Secondly, what is the ratio that these elements are bonded to one another, right? Because if I don't have this bond, if I don't have 1 potassium, 1 nitrogen, and 3 oxygen, then that's not potassium nitrate. That's another kind of a compound, right? So I know that there's 1 potassium, 1 nitrogen, and 3 oxygen. And if I write it in a ratio, that's how it's going to know. Okay,
So,
yes?
ma'am, I just want to ask, like, what was I gonna say? So the 3 times what's this? The K and O, potassium and what? So, like, do you multiply that by the number of atoms the element has? Oh, okay, thank you, ma'am.
Yeah,
I get it now.
perfect. We call that the subscript, right? Okay, and then if you want to figure out how many atoms there are in total in this compound, then we just add them. 1 plus 1 plus 3, and then we'll get 5. Lesego, is it making sense? Okay, so Michael and Christopher has answered me. Your answers are correct. Well done. So we have 3K to 3N to 9O. Oh. 9O. Okay, because guys, it's 3 times 1 and 3 times 1 again, but then 3 times 3, which is 9. All right. Okay, so I'm only hearing answers from specific few. I'm not hearing that everyone's understanding this. It's making me feel like I can move on and just assume that you understand it. Okay, so any questions you need to ask me now. I get a bit of it. Do one more. Sure. Let's choose this one here.
Sorry, which one, ma'am?
I'm going to do another one. Just give me a moment. Okay. Guys, so let's look at this compound over here. It says calculate the number of atoms for each element in the compound calcium carbonate. Right? So remember that we have, whenever we have CO3, it translates to carbon 8. Okay, tell me which elements are in the compound of calcium carbonate. Just name me the elements in the chat. calcium, yes. Oxygen, yes. And what is C? Calcium is Ca, and then C stands for something different. This is the element that consists, that diamond is made out of. Diamond and coal. Okay, I'm giving it to you guys. Carbon. All right, guys? Yes. Well done, Lesejo. Carbon, right? Okay, in the ratio, right, in the ratio in which the elements calcium to carbon to oxygen is bonded, give me the ratio, guys. The ratio is just how many atoms of each element are in the compound, and just give me the number, don't give me the symbol. And count. And Kiana, I want answers from you as well. Okay, so it's 1:1:3. Well done, guys. Just gonna highlight that. Right, so this means that they are 1 calcium to 1 carbon to 3 oxygen atoms in the compound of calcium carbonate, right? In total, how many atoms are there? If you can count that. 5. Yes, there are 5. Okay. Now, guys, let's make it a little bit trickier, right? If I add the coefficient of 4 before the compound name, now tell me, what is the ratio of elements in the compound? And I want answers from Sibu, I want answers from Kayla, I want answers from Amy, Gabby. All of you need to try. Well done, Michael. Wow, Michael is on a roll today. So 4:4:12. Yeah, right. How do we get this? So we say the coefficient times everything inside. So I don't know if you guys are doing this in maths, but imagine that there's a bracket. There's an imaginary bracket next to the coefficient. And you know that you need to times everything inside the brackets by everything that's outside. So 4 times 1, and 4 times 1 again, and 4 times 3. Yes, well done, Gabby. Okay, moving on. So if we have to put a symbol and a number in a ratio, then it will be 4 calcium to 4 carbon is to 12 oxygen. Okay. All right. Calculate how many atoms there are in total in this compound. Well done, Lesejo. That was fast. So there are 20 altogether. Okay, that is a lot, guys. Okay, let's do one more. Shall I do one more, or do you guys get it?
You get it, man.
Okay. The rest of you, well done, Ted. Well done, Gabby. Do I need to do it again? Do I need to do another example?
Please, no, man, yo. I'm sleeping. Yo.
Why are you sleeping?
I'm trying to keep up with the lesson. Eh? I was working for everything.
Okay. All right. So, guys, we're going to do one complicated one. All right. There are new rules for this, so just pay attention.
Okay.
All right, so we see that there are brackets in this compound here. Okay, we have nitrogen, we have hydrogen, we have carbon, and we have oxygen. Don't bother to name this compound, you don't have to. And I'm not going to give you a compound like this to name ever, all right? But I will give you a compound like this to calculate. So if we have brackets, guys, you're going to times whatever's in the brackets by everything that's outside the brackets first. So nitrogen has nothing, but it has an imaginary 1. So 1 times 2 and 4 times 2, right? Let's put this in, show you guys actually how it looks. So before we take the 2 and before we put the 2, we distribute the 2 to all the numbers inside the brackets. You're going to distribute everything within here, right? So now we have, it's going to look like this. Okay, just give me a second. Computer's freezing up a little bit. Okay, so right, this is how it looks after I've distributed everything in the brackets, right? Now I can calculate what's going on here. Okay, all right. I hope that wasn't too complicated for you guys, but basically what I'm just going to retract. What you're going to do is whenever you find a compound that has numbers outside the brackets, all right, you're going to times whatever's inside the brackets times whatever's outside the brackets. So that's exactly what I done. I said what's 1 times 2 and I got 2. What's 4 times 2 and I got 8. All right, let's take away the coefficient for now. I think it's going to be too confusing. Okay, so tell me what elements is consisted within this compound. What elements are found within the compound? So what is N, what is H, what is C, and what is O? Okay, Kian said nitrogen. H is not helium. He is helium. Carbon. Christopher said hydrogen. Well done. Oxygen. Yeah, that's about it, right? Yes, well done, Sefo and Michael as well. Okay, so now we need to know the ratio, right? So we have N is bonded to H, is bonded to C, is bonded to O. What is the ratio of this bond? Give it to me in numbers. So all you need to do is tell me how many N's there are, how many H's there are, how many C's, and how many O's. Remember that the number next to the symbol tells me how many atoms of that symbol there is in the compound. Michael says 2, 8, 1, and 3. Excellent, Michael. So there's 2, 8, 1, and 3. Well done. Okay, so in total, if we count how many atoms there are here, count for me. Okay, there are 14 atoms in the compound. Well done. All right, well done, guys. So this is basically the hard part over with. Let's go over some revision that we done from last week. Okay, so we have this compound over here, and we're going to attempt to answer that compound, right? So KCl consists of the elements. Give me the elements that are consistent within KCl. What is K and what is Cl? Well done. Potassium and chlorine. Okay. Right. The name of the metal, and I want Mo to answer this for me. Mo, what is the name of the metal in KCl? Is Cl the metal or is K the metal? Well done. Is potassium. Right. The name for Cl. We already answered that, which is chlorine. And the name of the compound. Right, so let's ask Michael. Give us the name of this compound. So we know this potassium, we know this chlorine. We put them together, we're putting a metal, and we're putting a non-metal together. And that's the first rule I taught you on Thursday. It ends with "ide". Well done. Potassium chloride. Okay, guys, we have like a few minutes left for this Zoom call before it like shuts down on me. So let's try to answer a few names. Okay, the first name, NaCl. Give it to me. On the chat.
Something chloride.
On the chat, Lee.
Beg your pardon?
Write it to me on the chat.
Oh no, I'm using my phone, but I can't write on the chat, man.
Okay, it's sodium chloride. So Na is the metal, which is sodium, and chlorine is the non-metal. And remember, when we put a non-metal and a metal together, we always name the metal first, and the non-metal goes last. And we add the suffix "ide" to the end of the name. Okay, MgCl2. Don't worry about the numbers, just give me the name. We also have a metal, magnesium, and we have a non-metal, chlorine. And I want you all to attempt this. Okay. Good. Next one.